We're going to talk about what a mapping is right now. Let's say we have a set of ordered pairs, and mappings work great for a finite set of ordered pairs. By finite, I mean you can count how many there are, as opposed to an infinite set of ordered pairs. Okay, so let's say we have the points 1, 2, 1, 4, and 3, 6. Let's just say we have that. Well, we can make what's called a mapping by using two, usually ovals. I've seen some books use like squares, or this book uses kind of some weird shape. But pretend like those are ovals. You put the input or the domain in the first one and the range in the second one. So my inputs are 1 and 3. By the way, I don't repeat that. I don't put 1 in there twice. Once it's in the domain, it's in the domain. If someone were to say, hey, what's the domain for this little set I have? You'd say 1 and 3. Okay, the range looks like it's 2, 4, and 6. Okay, the mapping, what we do is we draw an arrow from the domain element to the range element, or from the input to the output. So 1 maps to 2, 1 maps to 4, and 3 maps to 6. The number of arrows you have represents how many points you have. So I have 3 points, 3 arrows. Okay? All right, so this is called a mapping. I'm going to do another one. So let's say we have the set 1, 2, usually we put a comma between those 3, 4. And so I'm not being super creative. And they don't have to be numbers. You can have other types of ordered pairs, like, you might be mapping a TV show to how much money they bring in from advertising or something like that. Okay, but here we have this little simple set, two ordered pairs. So the domain is 1 and 3, and the range is 2 and 4. The input and the output. So for the mapping, 1 maps to 2. They have a relationship. They make an ordered pair. 3 maps to 4. Then we're done. There are two points and 2 arrows. Okay. Then I'm going to have one more. So I'm going to have 1, 5, 2, 5, and 3, 5. I'm going to have 3 ordered pairs here. So my domain is going to be 1, 2, 3. My range is just 5. Okay? So if I'm doing a mapping, 1 maps to 5, 2 maps to 5, and 3 maps to 5. They all map to the same number. Okay. So that's what a mapping does. It's great for finite sets. It gives you a picture of what's going on. Now we want to relate this to a function. A function is when every input goes, I'm going to put maps, because we were doing mappings, maps to only one output. So in other words, you can't have an input going 2 different places. Okay? So if it's a function, it's still a relation. By the way, all of these are relations. All functions are relations. But to be a function, you have to have this extra rule, that every input maps to only one output. And then we say the output is a function of the input. So if it's true, if it's a function, here's what a function is. You can look for it at the definition in the book too, but it's pretty similar to that. Then we can say the output is, if it's true, if it's a function, then the output is a function of the input. You might want to remember this for some of the questions that are going to come later. Okay, so let's look at our 3 relations over here. this one, and this one. So do we think the first one is a function? Does every input, so these are the inputs, go to only one output? No, not a function. And why? Because see, the 1 goes to 2 and the 1 also goes to 4. So see how the 1 is being repeated in the input? It's going 2 different places. That's not a function. All right, what about the second one? Do you think that's a function? Yes, this is a function. Where can I write it? This one's a function because the 1 only goes one place, the 3 only goes one place. Okay. What about the last one? Do you think that one's a function? I'm letting you think. Yeah, it's a function. Because the 1 only goes one place, the 2 only goes one place, the 3 only goes one place. So yeah, it's a function. They all go to the same place, but that's okay. All right? So that's how you know if something is a function. Mappings are really handy that way. Okay. Now they give us this little menu. Apparently we're buying donuts. It says, is the price a function of the item? Okay, so the item, that would be then the input. Now how do you know which one's which? Go back to what we said here. Okay? The output is a function of the input. Okay, so is the price, so this would be the output, a function of the item, which would be the input. I would say the donut, but anyway. All right, so what do we have for our donuts? We have plain, jelly, and chocolate. What is the output? Well, that's going to be the price. And the price is, we got $1.49 and we got $1.99. Those are the only outputs we have. Okay, so the mapping goes like this. Plain maps to $1.49, the jelly maps to $1.99, and the chocolate maps to $1.99. Is that a function? Yes, this is a function. Okay. I was going to say something about the donuts. I don't remember. Okay, so the item is, or I'm sorry, the price is a function of the item. Oh, it wouldn't make sense. You can't have a plain donut costing 2 different things, right? Like all the plain donuts have to be $1.49. Like you can't have them, some of them be $1.49 and some of them be, $2.09 or something like that. So otherwise your menu would be all messed up. Okay, now the second part of this says, is the item, so now we've got, this is being the output, if a function of the price, and this would be the input. Okay, so the input is the price, and we've got $1.49 and $1.99, and then the output is the type of donut. We got plain, jelly, and chocolate. Okay, well, the $1.49 goes to the plain donut, but the $1.99 goes to the jelly donut, and the $1.99 goes to the chocolate donut. So, is the item a function of the price? Not a function here. Because the $1.99 is going 2 different places. So I know that's a long video, but it's kind of an important one to really get our minds wrapped around what a function is and how we can tell if something's a function